Thank you, everyone. Really happy to be here. My name is James Murdoch. I'm a product marketing engineer at Texas Instruments, focusing on Bluetooth Low Energy, Zigbee, low power connectivity solutions. So really happy to be here in Singapore. Oh, and I wanted to mention the Google Fast Pairing thing. In our low power connectivity solutions group, which is separate from the Wi-Fi, we are actually working on that right now. We don't have an exact date, but that's something I encourage you to contact your local FAE, and we'll keep you updated. That is something that's in the pipeline. So today, my goal is to mostly explain to you a little bit about some of our upcoming, our recently RTM'd released to market products. I'm not going to focus so many details on like Bluetooth trends, but kind of more explain to you some of our new products and some things you can do with them. So that's going to be my approach today. So the two new products we'll be focusing on are the 2340R5. This is our latest in our 4th generation of Bluetooth low energy products, or also Zigbee. It's very streamlined and cost optimized. And I'm also going to talk to you about the 2674X10, where the X can be the R or the P. This is our more high-end Bluetooth product. So if you have like a use case where you need more computing power or more fancy chip, if you will, this would be one that you would want to consider. So we're going to cover the low end and the high end. So first I'll give you an overview, and then I'll give you some top applications of each of the devices. And then I'll do a little bit more detail on 2 exciting trends that I see for each of these devices. On the 2340R5, which is what we call Find My Network, which is a really neat application that we're seeing in a lot of different companies right now. And then Matter on the 2674. I'm going to skip this. Okay. So this is our overall roadmap. I personally don't even really like this slide that much, but this is how we present the generations. We go by generation. So on the x-axis, you see how much memory we have, and then on the on the y-axis, how much memory, and on the x-axis, the generation. The reason I don't personally like this slide all that much is just because 3rd generation implies 4th is new, 3rd is old. It's not really true. We still have just recently added the 2674 to the 3rd generation. So there are pluses and minuses of both generations. Generally speaking, the 3rd generation was a very flexible generation. Had what we call, you could even consider it sort of like a multi-core light, where we had what was called, for example, a sensor controller, which was a separate dedicated core for reading a sensor, reading temperature, this sort of thing. It also had a separate M0, which was used to control the radio. Now, going to the 4th generation, we've really streamlined that. We've removed the sensor controller. The M0 that was used to control the radio has been replaced by some dedicated circuitry. And so generally going from 3rd to 4th, you get a much more streamlined approach, or a streamlined chip. That being said, the 3rd generation of devices is still got a place in many end applications. So in our 4th generation, the first devices that we're releasing are the 2340R5 and the 2340R2. So these are what we are calling our most cost-optimized devices that we've ever released at TI. So if you have a Bluetooth, and if you have an end equipment where you want to easily add Bluetooth or connectivity, 2340R5 and R2 are actually really good options because you can add the connectivity in a very cost-optimized way. Just as a side note, I was researching the other day like expected Bluetooth shipments over the next few years. And I think by 2027 was what I read, there's expected to be something like 2.8 billion Bluetooth products shipped every year. So in that sort of scenario, you definitely want to have a cost-optimized chip available because so many chips are shipping. So that's 2340R5. Those again, the kind of cost-optimized, and then 2674 is the very fancy, if you will, capable chip with a lot of flash, a lot of RAM, and a lot of IOs and security features. So I'll talk about those both in more detail. First, the 2340R5, which again is the kind of very cost-optimized device where you want to just add BLE to your application. We call it just add BLE. This is a really excellent streamlined device for several different reasons. I mean, most important is probably it's streamlined for very low cost applications, so you're not going to break your wallet adding BLE now to your end application. But in addition to that, it has really excellent performance. It has the M0 Cortex, which is designed for embedded processing applications where low power is very important. And then up to 512 KB of flash and 36 KB of RAM. With the 512 KB of flash, you can support, for example, over-the-air download or more advanced software features. It also has or enables you to have a very minimum BOM or bill of materials. So oftentimes when you're designing your product, you want to cut your costs by reducing your bill of materials. This one has the integrated Balun, which saves you on average 12 different passive components compared to previous generations of our devices. It also has, of course, integrated ADC, UART, SPI, and I2C, so you can integrate it with many devices on your board. Another great thing, this is unique to our portfolio for an industrial grade part. It's supporting up to 125 degrees C for an industrial grade part, which is quite unique for the sort of price point that we're offering this as well. 125C means you can easily put it in a light bulb. You can put it in an industrial environment, in a hot factory, without having too much to worry about. Performance. Okay, again, it's a very cost-optimized part, but we also offer very superior performance, especially with power consumption. Texas Instruments really leads the pack for what we would call like a sleepy device power consumption. Why is that? Because fundamentally, our transistors that we use to build our devices leak less than the transistors used in many of the other products on the market. And so because of that, when for a standard like Bluetooth, where you're going to be spending a lot of time in standby mode, where the chip is not actively transmitting or receiving, you need to have very low leakage current. So that's why our process enables that. So our standby current is only 700 nanoamps with full RAM retention. That's, I would say, half of, or maybe even 3 times less than what you typically see on the market. So with standby current so low, you can have very, very long battery lives, especially for those sleepy applications where your device just wakes up maybe occasionally to transmit some data. Or even for a regular BL Link, of course, most of the time your device will be in standby because BLE is just waking up occasionally to transmit packets back and forth, and then the device goes back to sleep. Other great thing, so with that standby current so low, for a typical BLE connection, 1 second connection interval, which means you wake up once a second to transmit some data, your total connection average current is only 6 microamps. So you can calculate then based on your battery size what your battery life will be with a 6 microamp average current draw. 8 dBm output power. Of course, with more output power, you're going to get much longer range. We tested this outdoors, and you're easily getting more, 100 meters outdoors. In an indoor environment where you have a lot of walls and obstructions, etc., you can typically get closer to 30 meters. Sensitivity -96, so you can do the link budget -96 to 8 dBm output power is a very good link budget. Now going to the nice thing for procurement folks, or if there are any procurement folks or purchasing folks in the room, the starting price of only 79 cents for 1K. So that's quite a nice price for all those features that you're getting. So we definitely encourage you to buy more. I won't talk too much on the right side just because I think we've covered this, or you probably are familiar with your local FAE, but of course we have a great ecosystem of tools, including a development kit that you can use to run your code and try out the solution, 24-hour E2E support, and of course we're backed by what we're saying is actually not just we're saying, but it is really objectively the industry's best supply chain, with all of these chips being made in our new factory in Utah, Lehi. Okay, so that's our cost-optimized device. Now on the sort of low end, if you will, so you don't have a lot of extra features. What about on the higher end? You have a more demanding scenario where you need to do a lot of computations, or maybe you need a higher level of security with secure storage, for example. Then we have recently released the 2674. This one just RTM'd also a few weeks ago. It's our first ARM Cortex M33 device with the floating point and DSP instructions and trust zone. So that means it's quite capable computationally, but also extremely secure. It has 1 mega flash and 296 KB of RAM. So tons of memory. You can do all sorts of stuff like, of course, over-the-air download, but also run more demanding stacks, such as the Matter stack, which we'll talk about a little bit later. Of course, integrated ADC, 4 UARTs, 4 SPIs, 2 I2Cs, and 2 I2Ss. So you can see with that sort of feature set or peripheral set, you can connect a lot of stuff on your board. Temperature range up to 105 C. Performance, standby current is a little bit higher, but you get with 296 KB of RAM retention. So again, Texas Instruments, because of our proprietary process, we really do lead the pack in standby current. And that, again, is enabling you very long battery time, lifetime, especially for sleepy type end equipments. 1.19 microamps for full RAM retention. So the BLE 1 second connection interval is around 10 microamps. TX output power up to 20 dBm with the P variant, if you buy the P variant. So for those home automation or industrial applications where you want a long range, you can get that with the 20 dBm. And then this obviously starting a little bit higher for 1KU, but please talk with your local TSR and we can find a good spot for you on the price curve. Same with the ecosystem as the previous device, backed by our ecosystem and our 24-hour support. So these are I won't spend too much time on these block diagrams just because you can read them afterward. But 2674 block diagram here, you can look at the slides afterward. I've already talked to this a bit, but quite a capable device. Again, with the 1 mega flash, 296 KB of RAM, M33. And then, of course, the block diagram for the 2340, which is the lower end. So you can read this afterward. But this device, again, is targeted where you just want to add Bluetooth. You don't need such a computationally enhanced device. Oh, apologies. I should emphasize 2340R5 comes in 2 flavors. Or 2340 comes in 2 flavors. The 2340R5, which has 512 KB, that's what the 5 means. And then the R2, oops, and 2340 R2. The 2 is for 256 KB. So there are scalable options there. If you want less flash and you don't need to do over-the-air download, then the R2 is probably a good option for you. Okay. Let's talk a bit about some of the top applications for each of these devices before we do a little bit more in depth on 2 of the exciting applications. So 2674, which is again the higher end device, where would you want to use such a high end device? So advanced access points, there's some statistic out there that if you're looking at access points, industrial access points almost always have Bluetooth as a feature now. And they use the Bluetooth on the access point for several different features or different applications. Of course, one is so that they can configure the industrial or enterprise access point, like if it's on the wall or something place difficult to interact with. And then there's also the application where they're adding beacons, using beacons from the Bluetooth device from the access point in like retail settings. And this is for finding if your device is near that access point and then sending you advertisements or something. So most enterprise access points now integrate some sort of Bluetooth device. 2674 does support coexistence, so you don't have to worry about the Wi-Fi Bluetooth coexistence. Peripheral rich equipment. Up to 42 IOs means 2674 is great if you have a device where you have like a lot of buttons, remotes, or if you have a lot of connected equipment on your PCB. Multi-protocol scenarios. 2674, and of course many of our other devices in our portfolio support what's called DMM, Dynamic Multi-Protocol Management. So that actually is a feature that makes it so that you can run Bluetooth and Zigbee all at the same time on an end equipment. So there are some scenarios where you want to maybe connect to your phone to an end device using Bluetooth, but you want the end device also to participate in a Zigbee network, for example, in a home automation environment. With DMM, that's possible, and both stacks will run concurrently, so you don't have to turn the device off or reset the device and reload the second stack. They'll both maintain both connections simultaneously. Computation-heavy equipment. So of course the ARM the M33 has the DSP and FT floating point instructions. So this enables you to do more advanced computations, like if you want to compute FFTs or something more rigorous, the 2674 is a really great option. We also have devices coming in our roadmap in the next couple of years that will have even more features that will enable you to do more advanced math. So that's something to also to be on the lookout for. And then Matter hubs. We'll talk a little bit more in depth about Matter in a moment, but 2674 is really what we would call our flagship device for Matter in our portfolio because it's got a lot of flash and a lot of RAM, so it can run the full Matter stack, which we'll talk about in a moment. So you can easily add it for your Matter applications. 2340R5. Now again, 2340R5 is a much lower cost, much more streamlined device. So it's really ideal for these applications where you want to proliferate connectivity all over the place. So for example, anti-loss tags, maybe small medical injectors, this sort of thing. So where we're seeing a lot of interest in medical, BGMs, blood glucose monitor, CGM, continuous glucose monitors, insulin pumps, blood pressure monitors, this sort of thing, just where you're adding connectivity. Building automation, security, HVAC systems, personal electronics, keyboards and mice, remote control, toys, gaming controllers. Now, one thing I want to note is our roadmap currently doesn't have USB, so the sorts of peripherals we're adding this to are non-USB peripherals. And then, of course, retail automation. We're seeing a lot of interest in electronic shelf labels because, again, it's such a low-cost device. You can easily, where you know, ESL is the electronic shelf label. If you go to the supermarket, you might see that they're not using paper labels any longer. They're just using an electronic label that they update with Bluetooth. The 2340R5 is really ideal for that. I will also note, if you are interested in ESLs, we will be supporting the Bluetooth ESL profile next year. So if you have any interest in that, please talk to me or one of the FAEs. Okay, so that's kind of, I give you a high-level overview of two of our recently RTM devices. Again, the 2340R5, which is like the low-end device, you add Bluetooth anywhere, and then the higher-end device, the 2674, where you want a more capable device. Now I want to spend a little bit more time telling you about some neat applications for both of these types of devices. First is on the 2340R5. So I don't have too many slides on this, but I just kind of show you one slide on it. It's for what we call Find My Network, or Apple Find My Network. And there's actually a Google version of this also coming, but we don't have a date on it yet. How does this work? Let's say you're probably all familiar with the Apple AirTags. You may be familiar. It's a thing that you can add to your wallet or your keychain, and you'll never lose your wallet, because then if you do lose it, you can open up your iPhone and click on the Find My Network app or on the Find My app and click My Wallet, and it'll show you where your wallet is. How does it work? So the way that these Find My Network works is you put a device like 2340R5 that has support for the Find My Network in a tag or in your end equipment. So end examples could be like the earbuds. If you want to never lose your earbud, you know, the wireless earbuds, you lose them all the time, right? I lose mine all the time. Or you want to put it on your pet, on your cat. When the device is lost and you click on the Find My Network app on your phone, what will happen is if the device is near another iOS device, iOS 13 or higher, it will automatically connect to one of those nearby devices anonymously without any personal information being divulged to that nearby device. And it'll connect back to Apple Cloud Server. And then on your Apple iPhone, you'll be able to see the approximate location of your lost device. So it kind of uses the existing Apple iPhones in the field or Apple iOS devices in the field as sort of an ad hoc or almost like a cellular network in a sense, where you're going to connect through those existing field devices back to the cloud, back to the person who lost the iPhone of the person who lost their device. Quite an exciting thing. I think why it's so exciting is if you look at those Apple AirTags, they're quite expensive. But now with the addition of 2340R5, which is quite a cost-optimized device, you can imagine adding an anti-loss tag to many, many types of end equipment at a very good price point. So, for example, if you want to add 2340R5 to a wallet, anti-loss wallet, anti-loss backpack, we're seeing a lot of interest adding the anti-loss technology to scooters, so two-wheelers, electronic bikes, anything that you might want to make sure you never lose it. It's a great application for adding 2340R5. This is available. So if you do want to use Find My Network, we actually have it on TI.com today. You can request access. It's a fairly straightforward process. You have to obtain what's called an MFI license to use the feature, but once you do that, then it's fairly straightforward. We can talk later about how you get that. Now, the reason I think it's exciting is because Find My Network has a huge TAM. There was an estimate that something like 112 million Find My Network devices, not just from Apple, but generally speaking, will ship every year. And again, it's because it's a great use case. You know, there's so many things you never want to lose. Maybe you put it in your shoe even, you know, if it's cheap enough. Where we're seeing some example I shouldn't even say this, but these are freely available on the web, on the internet, so you can see who's already adding. So like anti-loss tags, anti-loss tags, anti-loss backpacks, anti-loss wallets. Very cool application that is possible with the 2340R5. Okay, now that's the 2340R5. So you saw, again, that's the low end. So where you want to add Bluetooth just anywhere, you want to really have a low-cost option to add connectivity. 2340R5 is a great option. Now let's say, again, you have a higher-end application, 2674. Where would you want to add that? One great example is on Matter. What is Matter? This slide has a lot of details, but the way I understand Matter is it's essentially a way to solve the problem of interoperability in a home automation environment. So you may, for example, today already have a home automation environment in your house. Maybe it's Apple, maybe it's Google, maybe it's Amazon. The problem today is none of these ecosystems work together. So if you buy an Apple ecosystem, you have to buy end equipments. When I say end equipment, I mean like a fan or a light bulb that works in that ecosystem. This is great for Apple or Google, you know, if you're in their ecosystem, but it limits the ability of third parties to participate, because then let's say you're a third party developer and you want to sell end equipments for home environment. Well, you need to then develop a version of it for all these different ecosystems, and maybe you don't know who will be more successful. With Matter, all these ecosystems will start working together, and then that makes it a lot more attractive for third parties to develop home automation equipment. So like you can sell a fan now and it will work with all the different Matter devices. So Matter essentially is a new standard, kind of like Bluetooth is a standard. It's based on, it can be based on either Wi-Fi or Thread or 802.15.4. I'll show you in a second what the typical topology looks like. But that's basically what it is. It solves that interoperability problem. And 2674 happens to be a great device for that. And I'll tell you in a moment why. So first of all, though, why would you want to work with TI for Matter? Matter, of course, will be something that a lot of companies will be investing in because, again, it's going to be quite a growing trend. We have quite a bit of leadership in this. Since the Matter standard release just last year, we are already seeing we already have one customer shipping with, I can't tell you who, but we do have one customer shipping already. And we have quite a bit of leadership with up to 40 different end equipments that we're tracking. I won't spend too much. Oh, and the other reason, of course, is because our Matter stack is available today. So if you do want to start getting started on Matter, we can get you started with our Matter stack today on GitHub. Okay, so this is the typical Matter network topology. And we have a demo or video you can see later if you'd like. But the way it works is you have end equipments, like a light bulb or a fan, that you want to add to your home automation environment. What you have to do is, if you have a very low power end equipment, like a fan or something where you don't want to connect it to the wall, then you're going to want to use Matter over Thread. So what you'll do is you have your Bluetooth on your phone. You scan with your phone. You'll scan the end equipment. That will commission the end equipment to the Matter network. As shown in this diagram, you can also have Matter over Wi-Fi. But Wi-Fi is going to be a higher power consumption compared to Matter over Thread. So if you have an end equipment that's running on a battery, it would make more sense for that to run over Thread. And it might be confusing when I say Matter over Wi-Fi, Matter over Thread. What does that really mean? I'll show you in a moment a diagram that shows you the stack. But basically, Matter is like the top application layer. So underneath it is something else, like a communication protocol like Thread or Wi-Fi. So that's what I mean. So if you do have an end equipment like a fan, typically what you'll do is communicate with a border router, which also supports Matter. And then that border router, which could be from, again, Apple, Google, whoever, will then communicate over Wi-Fi to the access point and then go back to the cloud, which would enable the user to, control their end equipment with their phone through the cloud. Okay, this diagram is sort of trying to show, or this slide here, I try to explain in a little more detail, again, or with more clarity, what the Matter looks like. So here on this diagram right here, you can see Matter is an application layer that runs on top of either Thread right here or Wi-Fi. Or there are some other standards that can run over, but typically we're seeing uses or interest in running over Wi-Fi or Thread. Now, one of the things that's kind of confusing and I think is important to understand is for Matter, there are actually different types of, configurations that you can use. So I want to tell you a little bit about that so that you can see where 2674 might fit or 2340. So there's generally three types of configurations or architectures. There's the radio coprocessor, network coprocessor, and SoC. Generally speaking, we don't see much interest from customers in the NCP because it's so close to the RCP anyway. Let me go back here for a second. So if you look at this diagram, you have the border router and you have the end equipment. The border router needs to have a Linux host in it or a more powerful processor even than the 2674. So generally for the border router, the typical configuration is that you'll have a Linux host paired with a wireless device that runs Thread or the lower layers of the Matter stack. So a typical scenario is in your border router, you'll have a device, your Linux host paired with a lower cost wireless device like 2340R5, which we talked about earlier. But then on the end equipment, you do not have the need for such a powerful host. And so that the end equipment just needs to run the Matter stack. So the end equipment is where you would run the 2674. So this diagram, or this table is trying to show you where, what type of configurations are possible with different types of devices. You can focus on the 2674 and the 2340R5. So you can see 2674 can run the full Matter SoC. Going back to the stack, that's this one. So that means it can run the entire Matter stack. So you don't need any coprocessor or anything next to it to run Matter. The Matter stack is quite big. It's like a 600 KB size stack. And the reason it's such a big stack is because it's having to do all this translating between the different types of end equipment and ecosystems. So that's why you need a more powerful device like 2674. So what you can have is 2674 you can add to your end device because it can run the full Matter stack. And then on your border router, if you want to have, if you do want to make your border router, you would, for your wireless, you would select 2340R5 in the RCP configuration, talking with a host processor. So RCP stands for radio coprocessor. Okay, so different types of categories for Matter that you're seeing today, like lighting, actuators, switches, sensors, many. Matter is all API based, so there will be an API for different types of end equipment. And over time, they should, of course, add more. Skip that. So we do have the full Matter stack available on our GitHub today. You can also see how to get started on our E2E. We have a Matter Getting Started page that you can reference on how to actually use Matter and get started. And we have a video here that you can use to get started as well. Skip that. We supply the software, so that's all this is saying. Ooh. Yeah, a lot of collateral. So we have getting started guides. We have the GitHub Smart Lock example, E2E blog posts, everything you can need. And of course, I encourage you also to reach out to your friendly local FAE if you have any questions, and they can contact me as well. Okay, that's kind of it. So a summary, we have a lot of cool devices ranging from the low end, 2340R5, very cost optimized, just add BLE, all the way to the high end, ARM Cortex M33 processor, a lot of flash, a lot of RAM. Key takeaway, whatever your application is, we should be able to find a product to meet your requirements for Bluetooth low power connectivity. So please don't hesitate to ask based on your requirements. Thank you. Any questions? Thank you so much.
Any questions? If no questions, yeah, James, thanks for your time. So for this, we've come to the end of the session. I believe we have some survey that we will need your help to do. And besides that, we will be sending out what has been presented slides to everyone in about 2 weeks' time. And also, every presentation we do have a video recording. So the video recording will also be sent to everyone that has participated in about 2 weeks' time. Yeah, we do need your help to do this QR code. Yeah. For this post-seminar feedback. And the TI team, we will still be here for the next 30 to 1 hour. If anyone has any questions that you want to talk to us on the sideline, please feel free to let us know. Like you want to talk to James, Yuri, or Alan, on the PD, Wi-Fi, Bluetooth stuff. Yeah.
Adding on to the feedback, once you all have done your feedback, please do not close the page. You can head outside to the registration table and collect your door gift as well as appreciation gift for helping us do the feedback. Thank you.